In this video, we will solve a full-length problem on BCH coding. Here we are going to find the systematic as well as non-systematic BCH code. So I already told you that BCH code is a combination of the Galloway basics. So you are required to be known about Galloway basics, where you find minimal polynomials, as well as it is the you should have the prior knowledge of cyclic code, because BCH is a cyclic code. So the procedure used for designing the cyclic code is the same as BCH code, but there is one requirement from the student, that one full length problem which combines Galloway's field as well as cyclic code uh, should be covered or is required for better understanding. Although this video length will increase, but still if the student requires it, uh, it is formed for the students, so that they will come to know which part of Galloway's field and cyclic code they should know to design the BCH code. So before starting the video, I just want to remind you that you are forgetting to subscribe to the channel, because the likes and the shares on these channels are in multifolds daily, but the subscription is you are missing the subscription part, and this happens. We normally forget to subscribe to the channel. So before starting the video, so do subscribe to the channel, so you will get benefited with more such videos. Okay, so the problem given is design a BCH code with block length n equal to 7 and error correcting capability TC equal to 1 and 2. Find code words corresponding to following messages. Okay, so the what is the difference between cyclic code? Cyclic code and BCH code is that cyclic code corrects up to one error, but multiple error correcting capacity is there with BCH codes. So first we will so in BCH code they should first give you the code word length, that is 7 n and TC. So we will first take this one, n equal to 7 and TC equal to 1. So you got n and TC. Then first step is you have to find m. So m is equal to 2 raised to m is equal to n plus 1. So 2 raised to m is equal to 7 plus 1, that is equal to 8. So 2 raised to m is equal to 8. So m equal to 3. So m you are getting it as 3. Then after that, why this m is required? This m decides the degree of primitive polynomial. So from this m you have to find the primitive polynomial. So how to find the primitive polynomial? So you have to find the primitive polynomial of order 3. So why this is required? Because you have to construct Galloway's field 2 raised to 3. Here also 3 comes, 2 raised to m. So 2 raised to 3 and primitive polynomial of order 3. So why? Because we need minimal polynomials to construct generator polynomial for the BCH code. So the primitive polynomial is of order 3, that means it's a 4-bit representation. So you know that numbers 8 to 15 are represented with 4 bits. Among these numbers, 11 and 13 are prime numbers. So among these 4-bit represented numbers, it's a binary representation. So among 4-bit binary represented numbers, you have to select prime numbers. So 11 and 13 are prime numbers. So 11 is represented as 1011 and 13 as 1101. So in the polynomial form, you know that it is a 4-bit. So this corresponds to x cube. This is x square, this x and 1. So 0 is there, so x square is not there. So x cube plus x plus 1. So here x cube plus x square plus 1. So this is polynomial representation of these numbers. Now this is the first criteria for selecting primitive polynomial, that the number is prime. After that you have to see whether these polynomials has roots in the Galloway's field 2. So in Galloway's field 2, because base field is Galloway's field 2 and we are constructing extension field from the base field. So in Galloway's field 2 there are two elements, 0 and 1. So you have to say whether 0 and 1 are the roots of these polynomials. So let us check x cube plus x plus 1. So if you put 0 here, you will get 1. So 0 is not a root. If you put 1 here, so 1 plus 1 is 0, 0 plus 1 is 1. So it is mod 2 operation. So 1 is also not a root. So 0 and 1 are not roots of x cube plus x plus 1. So it is irreducible over Galois field 2. Similarly, for x cube plus x square plus 1, if you put 0, you will get, if you put 0 in x, you will get 1. So it is not the root of x cube plus x square plus 1. If you put 1 here, there also 1 plus 1 then is equal to 0, 0 plus 1 is equal to 1. So it is a mod 2 operation, Galois field 2 operation. So it is also 0 and 1 are not roots of this polynomial also. So both these polynomials are irreducible over Galois field 2. So in mod 2 operation, you have to remember that 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 0. Okay, so first what we have seen, we have find the m. So we have find the m from n, that is equal to 3. Then we have to select primitive polynomial of order 3. For that, order 3 is represented with 4-bit representation. So in binary, you know that 8 to 15 are represented with 4-bit. Among them, 11 and 13 are the prime numbers. After that, you have to see the polynomial form from the prime number, whether they are irreducible over Galois field 2. That means whether they have roots as 0 or 1. So if they are irreducible over Galois field 2, that means they don't have the roots as 0 and 1, then they are called irreducible over Galois field 2. Such polynomials which are formed from the prime numbers and irreducible over Galois field 2 can be selected as primitive polynomial. So this is the criteria. So either of them can be used to construct Galois field 2 raised to 3. Either of them can be used to construct Galois field 2 raised to 3. So we are constructing Galois field 2 raised to 3 with primitive polynomial x cube plus x plus 1. So Galois field 2 raised to 3 means 8 elements. The extension field elements can be expressed as powers of alpha. So 0, 1, alpha, alpha square, alpha cube, alpha 4, alpha 5, alpha 6 are the elements of Galois field 2 raised to 3. Alpha is the primitive element. So here you have to remember that alpha raised to 7 is equal to 1. This is required. All this part is already covered in detail on this channel. Still, to have the flow or to have the better understanding how the things go for BCH course, we are covering this part. So alpha raised to 7 is equal to 1. So alpha is a primitive element. Extension fields, every element, extension fields, this is extension field created from Galois field 2. Extension fields, every element can be expressed as powers of alpha. And it is Galois field 8, so alpha raised to 7 is equal to 1. This you have to remember. So a primitive polynomial you are using is x cube plus x plus 1. So alpha is the root of primitive polynomial. Alpha is the root of primitive polynomial. This you have to remember. Alpha is the root of primitive polynomial. All these elements can be expressed as mod of this primitive polynomial. Mod of this primitive polynomial. So what are the values of these elements as a mod of this primitive polynomial is you can observe below. So for that you have to put alpha as a root for this primitive polynomial. So alpha cube plus alpha plus 1 is equal to 0 because alpha is the root of this primitive polynomial. So alpha cube is equal to alpha plus 1. Alpha cube is equal to minus alpha minus 1, but 1 plus 1 is equal to 0. That is 1 equal to minus 1. So alpha cube is equal to alpha plus 1. Alpha 4 is alpha into alpha cube, alpha into alpha plus 1, that is alpha square plus alpha. Alpha 5 is alpha into alpha raised to 4, that is alpha square plus alpha, that is alpha cube plus alpha square. Alpha cube is alpha plus 1, so plus alpha square plus alpha plus 1. Alpha 6 is alpha into alpha 5, so alpha square plus alpha plus 1, that is alpha cube plus alpha square plus alpha. So alpha cube is alpha plus 1, alpha square plus alpha. So alpha gets cancelled out because similar terms 1 plus 1. So alpha gets cancelled out, so alpha square plus 1. Now what we have done, we have selected primitive polynomial, then we have written the elements of Galois field in terms of primitive element. Primitive element is the root of primitive polynomial. So we have obtained these elements, or we have obtained the equations for these elements in terms of mod of primitive polynomial. So after that we have to obtain the minimal polynomials. So for obtaining the minimal polynomials, there are the elements among these which have the same minimal polynomial, which are the roots of same minimal polynomial. That is called conjugate set. So how to find the conjugate set? So for finding the conjugate set, you have to start from alpha. So alpha's conjugates are its powers 2, 4, 8, 16, likewise 16, 32, 64, likewise. So you have to take alpha's power, alpha, alpha square, alpha 4, alpha 8, alpha 16. Now alpha 8 is likewise, you can go up to infinity. Alpha 8 is equal to alpha 7 into alpha. That's why you have to remember this. If it is Gauss field 8, alpha 7 is equal to 1. If it is Gauss field 16, then alpha 15 is equal to 1. So alpha 8 is equal to alpha 7 into alpha. So 1 into alpha. So alpha 8 is alpha. So alpha 8 is alpha. So alpha is repeating. First element is repeating in this set. So you have to stop here. Don't take alpha 8. And your set becomes alpha, alpha square, alpha raised to 4. All these elements are just a repetition of alpha, alpha square, alpha 4. Then alpha, alpha square, alpha 4. So set is alpha, alpha square, alpha 4. Now second set includes, so you have covered alpha, alpha square, alpha 4. Next odd element is alpha cube. Odd power is alpha cube. So take alpha cube. So alpha cube, it's 2, 4, 8 power. 2, 4, 8, 16. So alpha cube, alpha 6, 4 3s are 12. 8 3s are 24, 16 3s are 48. Likewise you can go. So where to stop? Alpha 12 is equal to alpha 7 into 5. Alpha 7 is equal to 1 into 5. That is alpha 5. Alpha 24 is alpha 7 into 3. 7 3 21 into alpha 3. So the 7 is equal, alpha 7 is equal to 1. So 1 into 3. So it is 1 into 3. 1 into 3, 1 raised to 3 is 1. So that is alpha cube. So alpha cube you are getting at alpha 24. Alpha cube you are getting at alpha 24. Skip alpha 24 and other elements. So the set becomes alpha cube, alpha 6, alpha 5. That is alpha cube, alpha 5, alpha 6. So after that you have to find the minimal polynomials. For finding the minimal polynomials, you require the equations which are formed as a mod of primitive polynomial. So which are obtained here. Alpha cube, alpha plus 1, alpha 4, alpha square plus alpha, alpha 5, alpha square plus alpha plus 1, and alpha 6 is alpha square plus 1. So minimal polynomials, one conjugate set is alpha, alpha square, alpha 4. They have the same minimal polynomial, that is x plus alpha square, x plus alpha raised to 4. The minimal polynomial for this is found by x plus alpha square, x plus alpha raised to 4. So the first you have to multiply this. So x square plus x alpha plus alpha square plus alpha cube, then x plus alpha raised to 4. Alpha plus alpha square is equal to alpha raised to 4. Plus alpha cube plus x plus alpha raised to 4. Again you have to multiply with x. So x cube plus x square plus x, then alpha raised to 4. Alpha raised to 4 x square, alpha raised to 8x, alpha raised to 7. After that x cube, x square is alpha 4 plus alpha 4. X is alpha cube plus alpha 8 and alpha 7. Alpha 4 is 0. X alpha cube, alpha 8 is alpha 7 into alpha. Alpha 7. Alpha 7 is equal to 1. Alpha cube, alpha 7 is equal to 1. So alpha cube is alpha plus 1. So that is alpha gets cancelled out. So the minimal polynomial for this set is x cube plus x plus 1, which is like a primitive polynomial, which has the root alpha, which has one of the root as alpha. Next set is alpha cube, alpha 5, alpha 6. This is another set. So for that you have to again multiply this. X square, x alpha cube plus alpha 5, parts 3, that is 8. So alpha 8, x plus alpha 6, x square plus x, alpha cube is alpha plus 1, alpha 5 is alpha square plus alpha plus 1, alpha 7 into alpha is alpha 8. So alpha plus alpha gets cancelled out, 1 gets cancelled out, so alpha square. So this, and alpha 7 is 1, so alpha. Again x multiply cube square x, alpha 6, alpha 6 plus 2, 8, 6 plus 1, 7. Again x cube, x square is alpha square plus alpha 6, x alpha plus alpha 8 plus alpha 7. So alpha square, alpha 6 is alpha square plus 1, so alpha square gets cancelled out. Then x alpha 8 is alpha 7 into alpha 7 is 1, so it is 1, so it gets cancelled out. So x is equal to 0 here, and x square is 1 is there, so so x square appears. So the minimal polynomial is x cube plus x square plus 1. This we have already covered on the channel. If you want in more detail, already I have told it in detail. Still, if you want, you can see that video. Now, so you got the minimal polynomials now. So after that, where is that part? After that, you have to form the table like this. So the elements are 0, 1, alpha, alpha square, alpha cube, alpha 4, alpha 5, alpha 6, 0, 0, 1, x plus 1, alpha minimal polynomial x cube plus x plus 1, alpha square x cube plus x plus 1, cube square 1, alpha 4, cube x 1, 5 cube x square plus 1, 6 alpha cube x cube plus x square plus 1. Alpha square alpha 4 has same minimal polynomial. Cube 5 6 has same minimal polynomial, that is x cube plus x square plus 1. After that your coding part comes. So till this you need Galois field basics. So BCH code they have given n equal to 7, t is equal to 1. Then you have to write 2tc is equal to 2. Now gx is LCM of minimal polynomials of alpha comma alpha square. Up to alpha 2tc you have to go. So 2tc is 2. So we have written up to square and its conjugates. So what is minimal polynomial of alpha? That is x cube plus x plus 1. What is minimal polynomial of alpha square? X cube plus x plus 1. Both are same, so LCM is 1. That is only 1. That is x cube plus x plus 1. So what is k? K you can find after finding the gx. Gx degree is 3. So k is equal to 7 minus gx degree. That is 3. That is k equal to 4. So this is 7, 4 code. Now d they have given. D is equal to 1011. Its polynomial is x cube. X square term is not there. So 0 x plus 1. So non-systematic code is, so this is cyclic procedure. So non-systematic is cx is equal to gx into dx. So gx is x cube plus x plus 1. This is gx into dx, x cube plus x plus 1. If you multiply this, you will get x6 plus x square plus 1. Similar terms you get cancelled out. So what is c then? x6 is 1, 5 is not there, so 0, 4, 0, 3, 0, x square 1, then x 0, 1. So this is code. This is like a cyclic code, cyclic procedure. After that, where is that? After that, if you want systematic BCH code, then you know the procedure that x raised to n minus k into dx divided by gx. You have to do this one. So x raised to n minus k is 7 minus 4, 3. Dx is x cube plus x plus 1. So what is dx? So dx is this one, x cube plus x plus 1. That is your dx. So your that is x6 plus x4 plus x cube. You have to divide it with x cube plus x plus 1. So x cube, what is gx? Gx is x cube plus x plus 1. Same, dx and gx are same here. Okay, so if you divide this with gx, you will first you will get the quotient as x cube, then multiply with all these terms. So x cube, x6, x4, x cube. So remainder is 0. So cx is remainder plus this part, x raised to n minus k into dx. This part is x6 plus x4 plus x cube. So x6 plus x4 plus x cube. So c is equal to 1011. So c is equal to rx is 0. C is x6 1, 5 0, 4 1, 3 1, 2 0, 1, x 0 and 1 is 0. So you can observe that d is 1011 and c you are getting as 1011 000. So this is systematic because you are first getting d, that is 1011 and 000. In case of non-systematic cyclic code, you are getting for 1011 non-systematic BCH. Cyclic, if I say cyclic, consider it as a BCH because the procedure is same and BCH is a cyclic code. So D is equal to 1011. For non-systematic, 1011 doesn't appear in the front. So parity and message bits are mixed in the non-systematic cyclic code. But in systematic cyclic code, message bits appears first and after that parity bits. So this you know in cyclic code. So let us take another. N equal to 7, Tc equal to 2. 2Tc equal to 2 into 2, 4. So LCM is minimal polynomial of alpha, alpha square, alpha cube, alpha raised to 4. 4 appears here. So you have to go up to alpha raised to 4 and its conjugate. So LCM of minimal polynomial of alpha is x cube plus x plus 1, alpha square x cube plus x plus 1. This table. Then alpha cube x cube plus x square plus 1, alpha 4 x cube plus x plus 1. So 3 times you are getting x cube plus x plus 1. For that, take it as single time, x cube plus x plus 1. This is LCM. Then x cube plus x square plus 1. If you multiply this, we have already done on this channel this multiplication, but it's very easy. Similar terms you get cancel it out. So you will get x6, x5, x4, x cube, x square plus x plus 1. So k equal to 7 minus 6, that is equal to 1. So k is 1. So if k is equal to 1, then d is either 0, or that means d means message, means k, number of bits k is equal to d. So d is equal to 0 or 1 only. So d is equal to 0, dx is equal to 0. Non-systematic BCH code is dx into gx. So gx, you got this one. Gx is this one for this combination. This is gx. 5, 4, 3, 2, x1. So cx is 0. Systematic BCH code is x raised to n minus k into dx. So x cube into 0. dx is 0. So that is 0 divided by gx. So this degree is very less than 6. So remainder is 0 only. So cx is x raised to n minus k dx, that is 0 plus rx, 0. So 0. So c is 0. So d is equal to 1, dx is equal to 1. Non-systematic BCH code is dx into gx, that is x6, x5, x4. That means all ones. Now systematic is code is d is equal to 1, dx is equal to 1. X raised to n minus k dx, x cube. Oh, right. K is here different, na? So here k is different. K is equal to 1, na? Yes, k is equal to 1. So 7 minus 1, 6. That's why I am getting wrong there. X6. But here doesn't do not have any impact. But here n minus k, here 6 is there. That's why my answer is different than your textbook. And here while making the video, I got the error. I got the error corrected. I was thinking too much, why I am not getting. So this is x6. So the division is 1. So it will be 1. Then x6 plus x5 plus x4 plus x cube plus x square plus x plus 1. So that is, this gets cancelled out. Remainder is x5 plus x4 plus x cube plus x square plus x plus 1. So this is wrong. I was thinking too much, but still I decided let us do the video, and here only I got the answer. So x raised to n minus k dx is x6, and remainder is this one, x5, x4, x cube plus x square plus x plus 1. So the answer is, so I was getting wrong answer. I decided to that I will tell, please find the answer, because I am getting wrong. But still I got the answer. So that is 1, 1, 1, 1, 6, 1, 2, 3, 4, 3, 4, 5, 6, 7. 7 bits. So all are covered. So C is 1. This one is the code. So K I was taking wrong. So this is the answer. So if you are liking the video, don't forget to subscribe to the channel.